Hello. Welcome.
Hello. I was going to say that the bit at the end with the LCD screen, I'm very impressed. That was very good.
I really enjoyed doing that. Yeah, a few nights. Oh God, now the coffee machine started to make a racket. Yeah, I really enjoyed doing that. And I was saying to the guys earlier, I finished off that intro last night and realised I spelled Arduino wrong in that code. So I had to go back, refilm it, re-edit the codes, and then do it all again. That was a nightmare, but we're here, and yeah, I've been looking forward to it all day. So,
Nice.
Welcome everyone to our new weekly show. We're not, well, I'm not a professional. I know a little bit, so I'm going to be learning along the way too. But I know some, and yeah, it's Mark's first time playing with this, so it's going to be really exciting. But yeah. So yeah, we're just going to start off with the basics. I mean, I know Mark's going to do out the box a few. They're going to do some lessons that you would get. It's worth noting when you get this kit, you get all the instructions with it. So if you fancy to go and you bought a kit, it comes with everything you need to get started. It comes with a CD-ROM, and I think you can download them online as well. You've got all the instructions of how to do it, what to do. So yeah, you're ready to go. What I will say before, I guess Mark's going to do the chat tonight, are you? Yeah. Just before we do the chat, everything we do tonight, you can do yourself without this kit if you want to. All you need to do is, I'm saying it now, just in case you want to join in with the show. If you go to tinkercad.com, www.tinkercad.com, you quickly sign up. It's like 2 minutes, sign in with Google. It's actually a simulator for this. So if you click on circuit, you'll be on your 3D modeling first, because it does 3D modeling, circuits, stuff like that. If you click on circuits, you can actually play along yourself, install all the components that we're going to use into the breadboard, and then you can actually write the code as well. So if you fancy joining along but don't have the kit, you can do so on that website or even after the show. But yeah, tinkercad.com, and then yeah, you can play along at home if you haven't got the kit.
Okay, so I'll go through the chat because we've got quite a lot actually.
Yeah.
So we've got, first of all, up in first is D. Harris, Evening Alex, Mark, and Young Jack.
Hello, D.
And then we've got Gillian Milne, Evening everyone.
Hi, Gillian.
And then we've got Dano's Universe. Hello, everyone. Looking forward to this new show. Good luck with it. Hope it goes well. Yeah. I've got a vision of blowing things up.
Yeah, thanks, Dano. And I know Dano actually signed up for Tinkercad last night, so I'm expecting to see your code flashing at the end of the show.
Okay. We've got model making trucker, Lewis. Good evening.
Hi, model making trucker.
And then we've got Jay's channel. Good evening, all. Good luck with this new venture. Hope it goes well and you have lots of fun.
Oh, we will. Thank you, Jay.
And then Yorkshire Crafter says hello, everyone.
Hi, Julie.
And then Jordy Day says hi, everyone.
Hi, Jordy.
And then we've got Anthony Watson. Hi, everyone.
Hiya.
And then here we go. We've got Jordy Dave. Hi, Yorkshire Crafter. Then we've got Yorkshire Crafter. Hi, Jordy Dave. And then we've got D. Harris. Evening, Gillian. And then we've got D. Harris at Dano's Universe. Good evening. And then we've got Gillian. Evening, D. And then D. Harris Model Making Trucker. Good evening. And then we've got Jay's channel. Good evening, man. And then we've got Model Making Trucker. Evening, D. How are you? Oh, gosh. And then we've got Dave Mark Bills. Good evening, everyone. Good luck with your new show tonight, guys.
Thank you, Dave. Hiya.
So, and then we've got D. Harris. All good, trucker. Love what you've done on that Lang. How's you? And then we've got D. Harris. Evening at Dave Mark Bills. How's you? And then we've got Dave Mark Bills saying, evening, D. I'm not too bad, thanks. And then we've got D. Harris. How's mum? And then we've got Model Making Trucker. Thank you. I've been better. The wife had an accident yesterday in my car. She's all fine, but my car is a possible write-off. Oh
no.
God.
Oh, no.
Sorry to hear that, Lewis and that. And then we've got Dave Mark Bills. She's fine, D. Thanks. How's things with you? We've got Dave McBills at Model Making Trucker. Glad your wife's okay. That's the main thing. D. Harris says, sod the car, Trucker. It can be replaced as long as she's good. And then D. Harris at Dave Mack. As good as can be, mate. And then Dave Mack. That's good, D. Daniel's Universe. Cool intro. That's all down to Horlicks here. I did the outro. Horlicks did the intro. And then we've got Model Making Trucker, thanks. And that's what I keep telling her, but she's female and doesn't listen to me. Oh, don't stop. Ian Campbell says, hi all.
Hi, Ian.
And then David Bassett says, good evening, Alex, Mark and Jack.
Hiya.
Amen.
And then we've got Alex Jameson, hey, beautiful. And I think that's at Horlicks.
Yes, that's
And then we've got Alex Jameson, and hey to the other two ladies.
Guys, they're guys. Cross wires.
D. Harris at Model Making Trucker, do they ever? Oh, we're going to start. Females are going to start kicking off in a minute.
Oh no.
And then we've got Model Making Trucker, mine doesn't. And then we've got Dave McBills at Model Making Trucker, mine's the same. And then David Bassett, we'll have to have a look at the website after the live stream, Alex.
Yeah.
And then we've got Ian's World of Models. Thanks for doing this, guys. Can't wait to learn. That's fine. And then D. Harris says, hi all on the other side. And then Johnny Dave says, hi Ian. And then David Bassett says, good luck with this new venture. And then Ian Campbell says, hi at Johnny Dave. And then Ian Campbell says, really looking forward to this new stream. Give everyone the ability to bring some of their builds to the next level.
Yeah, and that's exactly what we were discussing, wasn't it?
That's
Yeah.
what I said.
You know.
I like, and then we've got DM Harris saying, evening, Mr. Campbell. And that's the chat.
Wow, what a
Wow.
turnout.
Right, so what happened, what this all came about was Jack
It's
got
my fault.
me this for Christmas.
It's my fault. This is
Yeah, it's been a wish for quite a long time. So Jack bought me that for Christmas. So in the new year, I went to Alex and I said, you fancy doing a show on this? Alex, you hadn't done any for a while, had you? You didn't even know what your board was. So do you fancy doing a show, about how to do this so people can learn themselves? So after a lot of discussing, I then told Jack about it, and Jack was like, I'm buying one for myself. I'll be in the show. So basically, we've been sort of back and forth all through January. Decided to do it in the first Wednesday of February. And show people how these things work. I'm a complete novice. I've never done this before at all. Horlicks, you've done stuff in the past, haven't you? But a while ago.
Yeah, that's it. That's why, because when we spoke about it, we were eager just to get going, but I had to brush up a little bit because I got to a stage where I was at work and I had these ideas and I was writing code on a piece of paper on my lunch break. They're ready for when I got home, and I lost a lot of it. There was a lot going on in my life, obviously, and I just forgotten most of it. So I've had to brush up on it. So that's why I said February.
Yeah.
Just so I can.
So basically, we decided to do this show so we can show you how you can do this and what you can do with your models, basically, or anything really. You can go from doing this to 3D printing bits, can't you? As well. For them. So, there's a lot you can do. So this is why we're doing this show, and hopefully it'll work and everybody be out there now modding the models and putting bits and pieces in. So, okay, Jack, do you want to say a little bit about yourself?
Hi. I think most of you see me on the Northern Model Builders show. Well, I haven't been there for like 5 weeks because I have nothing to do. But I stream on Twitch. I think it is live there now, but I don't know. It's something goes on when I open Stream Manager on Twitch and it just lags. So I don't have it open at the moment. But I stream on Twitch Monday, Friday, Saturday, occasionally at 8, and then which is mostly gaming. This is new, so this is really new. All right, that's my piece.
Okay. Right, shall we get started? Oh, hang on, I'll just catch up with chat. So we've got White Good Models. Hi, I'm here. Hi, everyone. Hi, Kaylin at White Good Models. And then we've got Ian Campbell saying hi, you D. Then we've got White Granola saying epic. Then we've got Ian Campbell saying hi, Kaelan. And then we've got Kaelan saying hi, Ian. And that's the chat brought up to date.
Hi, White Graph Models. Yeah, this turnout was amazing. Thank you, everyone, for joining us. Right.
Yeah, definitely. Right. Do you want to do your bit first, Alex?
I don't mind. I mean, mine's a little bit more advanced. So did you want to get on and do what you want? Yeah, because then mine will follow on from yours. Mine's a similar thing, but a bit more advanced.
Right. Okay.
So yeah, no, I'll let you do what you need to do, and then I'll
change the camera. But I need to mute to tell the device to do something. Else everybody's going off.
I want to change my camera as well.
Right, camera and mic. Right, I'll go full screen just for now, if I can. Okay, so this is the kit. It's on Amazon. That's where this came from. And basically, you open it up. You've got a disc which has, I'm doing it on a different thing here. You've got a disc which basically is all the software and where you can go download it and everything, and the lessons as well. And then basically, this is it. So this is the board, which I'll take it out of its static bag in a second. You've got a bit of a smaller breadboard there. We're going to need this wire as well to connect it to the computer. We're going to need some more wires. And then you have at the bottom of here got a bigger breadboard, which I will be using tonight.
I think, because it actually doesn't say, it doesn't actually show that.
No, I'll just put that to one side. I'm probably going to need a resistor at some point. So, get into this. This is probably never going to go away now, you know.
Once you get started, you'll be addicted. I was.
Yeah.
Computer programming is very, very not addictive, but it's very satisfying.
Yeah.
Right. So get the wire. Oh, great! That's not going to be long enough.
Yeah, I was going to say they're quite short. I've got an extender on mine, but
I might have an extender I can give you.
I've got an extender. It's just
I don't have everything upstairs.
Let's get this board open. And there you have the board.
Ooh.
I don't know, it has double-sided tape on the back of it.
Yeah, that's right.
Double-sided tape on the back.
On the
No, on the breadboard.
Oh, on the breadboard. Well, I suppose that's if you want to permanently fix it.
Yeah.
Right, I just need an extension cable. I have one. Just finding out where it's going to. Oh, wrong camera.
Whoops.
Pulled out the wrong device.
Oh, that's all right. No worries. We always have a technical issue, don't we, at some point? So it's good.
Yeah.
Yes, but not on the first one.
Yeah, it wouldn't be.
That's not great.
Technical issues are allowed to happen.
Hang on, go back to you two for a second while I sort this.
So yeah, I mean, mine's exactly the same. Mine's blue, and I've actually 3D printed this little case for it, just so it all sits in it as a one unit. Just makes it a bit easier, really, when you're working.
Yeah. Also, it makes it easier to know which wire has gone where.
Yeah. So let me go for a little bit of this chat quick.
Yeah.
So we've got so Alex Jameson says gaming, you say, Jack, and he's asking what games.
Mostly Apex. Sometimes Rocket League, sometimes Minecraft. But yeah, mostly Apex.
Lovely. We've got Jodie Dave saying hi at D Harris. And then we've got Alex Jameson saying, no, I can't see you, Mark, and sad faces. And then,
All right.
come back, I miss you.
Right, I'll plug this board in.
Okay.
Cable's been a bit weird. Oh, I got it. Nice. There we go. Ooh.
Right, it hasn't said that video was. Does not recognise it, so presumably.
Well, no, it tells you how to connect it to the board and stuff. You scroll down.
Yeah, you have to go through your manual and set up some things in the app.
Yeah. Which isn't an issue.
Right, hang on. Just finding it all now.
Oh, we show this part though. I mean, the light's already blinking. Task, yeah. That's 2 done.
Right, I'm just looking through the manual now. Do-do-do-do. Right.
And we've got some more chat. We've got D Harris saying good, Jodie Dave, good evening. So there you go.
Right. Yeah. It's done. Oh, no. The good thing about this is it works on Mac and it works on Linux as well.
Yes.
Yeah, that's really good. So whatever system you're on.
Yeah, I've used Linux for a long time.
So I can't remember. Obviously, most computers these days don't actually have CD-ROM drives. I mean, laptops do and stuff. But are you getting your Arduino software off the internet or?
Yes.
Yeah.
Because it's constantly updating.
Mm-hmm.
So, I mean, I went to the place where you normally download it, downloaded the version, went to open it, and it turned around and said, no, there's another version that an updated version.
Yeah.
So it's constantly updating. Right. Here we go. Right. So it says making a connection. Serial monitor comes with any of all versions of Arduino IDE. To open it, simply click the serial monitor icon. Right, so.
What changed?
What changed?
When you get down to the port, changing the port, it doesn't have COM26. It's the one that says Arduino Uno in the brackets.
Right. See, now I've just opened it up and it says there's another download.
I haven't done any of the downloads. I've just kept it on the same version.
Yeah, that's what I'm going to do for now.
Yeah, because you have to re-download the entire thing. I looked at it earlier and I was just like, this is going to take too long.
Right, so selecting which port to open in Serial Monitor is the same as selecting a port for uploading Arduino code. Go to Tools, Serial Port, or Port, and select the thing.
Okay, Whitecraft Models says, Mark Mods, can you add a link to where you can download the software for the Arduino, please? Yeah, I can do that. That's fine while he's doing that.
Are you okay? Yeah.
So,
why is that blinking so much?
just click on the top bar.
Which one?
On the screen share, click on the top bar.
Oh, there. I got it.
Little glitch. Mine does that. So I've just posted the link there, White Glove Models. Is this the Tinkercad? No. So if you've actually got the actual Arduino physically in front of you, you use this Arduino software, which I've put the link in for. If you haven't got a Arduino and you want to do it virtually, you could go to tinkercad.com and you can play on there without actually having the physical electronics here. It's like a simulation website. I hope that makes sense.
Right. It says in settings, the serial monitor has limited settings, but enough to handle most of your serial communication needs. The first setting you can alter is the baud rate. Click on the baud rate drop-down menu to select the correct baud rate. Right.
Okay. So if you need any help, I can look at mine.
Wait, which one are you struggling with?
Serial monitor.
Serial monitor. Well, the baud type and serial part.
He's just testing it now, actually.
Loading a point. Finally, the status will change to done. The message tells that the sketch is 28 bytes. Oh, you could get the following error message. I mean, the baud is not connected at all. The drivers have not been installed. Or the wrong serial part is selected. If you can't discover, okay, right, less than 0 and check the installation. That's fine. Power sketch composed elements. Right. Well, this is what I was talking about earlier. Single line comments start with the double slash. So when you're programming, if you do a double slash, I don't think I'll let me change this, will it? No, I don't change this for some reason. Oh well. Oh. Okay, I didn't click on that. But yeah, you can do double slash, and then everything after that double slash on the same line is considered a comment. It doesn't actually alter anything to do with your code.
Yes.
But what you can see in here, in the actual code, it uses /, just one /, and then an asterisk. That's multi-line comment, where until you put another asterisk and a /, all of that section will be a comment.
Yeah.
And invisible to the actual code that uploads.
Yeah.
Right. It says I can put it onto auto scroll, which I've done. Right.
Yours is stuff linking.
Right.
See, mine's stopped blinking. Mine's just constantly on now.
That should be fine because I don't think the code would be uploaded to make it blink.
No.
Because that's your first lesson, isn't it? Blinking LED?
Yes.
Yeah.
Okay, so this is it. Lesson 2. We're going to make this LED blink. So, in this lesson, you will learn how to program your Uno R3 controller board to blink the Arduino's built-in LED and how to program the basic steps. And it just says component required Elegoo Uno R3.
Yeah.
And then it says here, the Uno R3 board has rows of connectors along the sides that are used to connect several electronic devices and plug-in shields that extends its capability. It also has a single LED that you can control from your sketches. This LED is built onto the Uno R3 board and is often referred to as the L LED, as this is how it is labelled on the board. Yeah.
Yeah.
Okay. You may find that your Uno R3 board L LED already blinks when you connect it to the USB plug. This is because the boards are generally shipped with the Blink sketch pre-installed. In this lesson, we will reprogram the Una R3 board with our own Blink sketch and then change the rate at which it blinks. It says then in lesson 0, you set up your Arduino ID and make sure that you could find the right serial port to connect your Una R3 board. The time has now come to put that connection to the test and program your Una R3 board. Okay. The Arduino IDE includes a large collection of example sketches that you can load up and use. This includes a sample sketch for making the LED blink. Load the Blink sketch that you will find in the IDE's menu system under File Examples. Examples 01 Basics. Right, okay. Right, when the sketch window is open, enlarge it so that you can see the entire sketch in the window. Right, this is where I'm going to have to share screen now.
Well, basically use the top sketch. You do what the top sketch does. You go examples 01 dot basics, and then you press blink.
Right, hang on. I'm sharing my screen so they can see me write the code. That's what I was thinking.
You're not writing code at the moment.
No, I'm not. So go to sketch and to blink. Okay. Sketch.
No, you go file, examples.
Yeah.
Basics, then blink.
File, examples, and we want blink.
Which is in basics.
Yeah. Okay. Now, can I move that over there? Yes, I can. Okay, when the sketch window opens, enlarge it so that you can see the entire sketch in the window. Attach your Arduino board to your computer with the USB cable and check that the board type and serial part are set correctly, which we've gone through. Yeah, it's telling you how to do that, but we've done that. Okay. Note the board. Oh gosh. Note the board type and serial part here are not necessarily the same as shown in picture. If you're using a 2560, then you'll have to choose Mega 2560 as the board type. Other choices can be made in the same manner. So this is basically if you've got different boards.
Yeah.
So there are different boards out there, and the serial port displayed for everyone is different. Despite COM26 chosen here, it could be COM3 or COM4 on your computer. A right COM port is supposed to be COMX Arduino XXX, which is by the certification criteria. Get it right.
X is just the number of your port, and then the XXX is, we should say Arduino, and then what type of Arduino board you're using.
Yeah, which we've done. Right. Right. Okay. So here we go. Single line comments start with //
You've skipped an entire section out.
Where?
You have to actually upload the Blinker file to the board. So you go from where you stopped after red. It says the Arduino IDE will show it.
Okay,
you have to upload it.
The Arduino IDE will show you the current settings for the board at the bottom of the window. Click on the upload button, the second button from the left of the toolbar.
In the Blink Arduino file.
Compiling sketch, it's saying. Uploading.
Yes, sir.
Done uploading.
I can see a
that's it.
blinking light.
Yeah.
It says here, if you watch the status area of the IDE, you will see a progress bar with a series of messages. At first, it'll say compiling sketch, which it did.
Yeah.
This converts the sketch into a format suitable for uploading the board.
Yeah.
So it'll give you a progress bar basically. The next the status will change to uploading. At this point, the LEDs on the Arduino should start to flicker as the sketch is transferred.
Yay. Well,
Finally, the status will change to done. The other message tells us that the sketch is using 198 bytes of the 32,256 bytes available. After the compiling sketch stage, you could get the following error message. It's going to mean that your board is not connected at all, or the driver's not been installed, and it basically just says if this happens, go back to lesson 0.
And also, if the sketch is wrong, if you type, it happens to me a lot. If there's an error in the code you've written, you will get one of them.
Right. Okay. Right. Okay, so here we go. Single line comments start with a / and everything up until the end of that line is considered a comment. The first line of code is int LED equals 13. Right, as the comment above, it explains that is giving a name to the pin that the LED is attached to. Right. Yes.
See, there's that. I mean, my code doesn't have that, I don't think. I don't know what's happening there. For some reason, my code doesn't have that.
Because we're not referring to a pin, because you haven't actually wired an LED to pin 13, it's using the command LED built in. But as far as I'm aware, the built-in one will also copy to pin 13 as well, I think. That I would have to confirm.
Okay.
But
right. This is 30. Right. Okay. Yes. This is 13 on most Arduinos, including the Uno and Leonardo. Next, we have the setup function again. As the comment says, this is executed when the reset button is pressed. It is also executed whenever the board resets for any reason, such as power first being applied to it, or after a sketch has been uploaded. So, void setup / initialize the digital pin as an output pin node LED output. Okay. Every Arduino sketch must have a setup function, and the place where you might want to add instructions of your own is between the and the right. Okay.
Right, so they're braces.
Right. God, I haven't seen them in a while.
Yeah, it's very strange code. And do you know what? It can be, if you're writing a big code like I did. You've seen, Mark, that sketch I did with the whole light show I did years ago.
Yeah.
I was having so much trouble, and it was just one of those braces in the wrong place causing me hours of work.
Right. In case there is just one command there, which, as the comment states, tells the Arduino board that we are going to use the LED pin as an output. It is also mandatory for a sketch to have a loop function. Unlike this, the setup function that only runs once after a reset. The loop function will, after it has finished running, it commands immediately start again. Wow. Okay. So, void loop. Right.
Basically what it means is it says that while the code is running, after the startup sequence has happened, it just loops that singular piece of block of code over and over and over again until you tell it to stop.
Yeah. Right. Okay, so that's what that's telling. Okay.
Mm-hmm. That's setting a delay to when it comes on and off.
Right. Okay. I think I'm get in there with it.
Well, no, it actually says that there. It says inside the loop function, the commands first of all turn the LED pin on high, then delay for 1,000 milliseconds, and turn the LED pin off. Pause for another second.
Right.
Yeah.
Okay.
So obviously, Arduino works in milliseconds. So yeah, 1,000 milliseconds is obviously a second. So you can change those values yourself depending on how quick or fast you want things to blink, or whatever you're doing, whatever project you're building there. That's how you control what happens and when.
Right. Okay. Inside the loop function, the commands first of all turn the LED pin on is commanded by high. Then the delay for 1,000 milliseconds, 1 second. Then turn the LED pin off and pause for another second. You are now going to make your LED blink faster. As you might have guessed, the key to this lies in changing the parameter for the delay command. Okay.
Parameter is basically just whatever in the delay brackets.
Yeah. Okay. The delay period is in milliseconds, so if you want the LED to blink twice as fast, change the volume from 1,000 to 500. This would then pause for half a second each delay rather than a whole second. Upload the sketch again and you should see the LED start to blink more quickly. Right, okay. So, 1,000 that I need to change to 500. And it needs to be after high. Hang on. What? So let's have a look. So start there, and that wants to change to 500. Okay, upload.
Yep.
Oh, okay, I got an error message. Error compiling board Arduino Uno.
I know why I've done that wrong. That still seems the same to me.
Yeah, mine hasn't changed to blinking.
I've changed the 1,000 to 500, and that's the same.
On both of them?
Yeah.
And then re-uploaded?
Yes.
Oh.
Does that does look like the same, doesn't it?
Mine's working.
Okay, so tell you what, Mark. Try changing it to 100.
Mm-hmm.
Then you should see a noticeable difference.
Is it just me not seeing it?
See, when it changes the upload, it should. Yeah. It should blink I think the RX and TX lights.
Right, basically we've made that blinking light flash. Faster. That's awesome.
Have you done it at 100?
Yes.
Yeah, it's going pretty quick, isn't it?
Yeah. Wow. That's really good.
And then you could go the other way and you could change it to 5,000 and then you'll have a solid light for 5 seconds.
Yeah. And that is my lesson.
That's
lesson 2 done. So it's over to you now, Alex.
God. Okay.
Hang on, can I just share this?
Yeah, of course.
Yeah, just let me just share this.
I want to stop sharing my screen.
I just want to show people what I did. So down here is the numbers for the delay. They were set at 1,000 and we changed these numbers down here to 100 and then press that to upload it and that's how it made it go faster. So just simple changing of the numbers.
Mm-hmm.
Oh, right, Alex, it's all yours.
God. Okay, so I'm going to do something a little bit more technical. So, let me share my screen. I've
I hope
already got.
everybody enjoyed that.
I have got my Arduino already, my software, and I'm doing a completely brand new sketch. I'm going to delete everything. So I'll sort of explain what I'm doing as I go. So what we're going to do is we're going to replicate a set of road traffic lights. So I'm going to write the code first, and then we will build the circuit on the board. Shouldn't take too long, and then hopefully it'll work. And I'm actually going to make a deliberate error so you can see what happens if you get the code wrong, and hopefully, yeah.
Let's.
You'll learn something. So,
green, Alex. There we go.
There we go. So the first thing we're going to do is we need to declare the variables. So the integer variables. Basically, all this is doing is you're giving a pin on the Arduino board. I'll show you more in detail afterwards. You've got different pins. You've got pin 0 up to 13. They're the pins that you can use depending on what you're connecting and stuff. So we need to tell what pin you're connecting stuff to. So to do that, to do your variables, you start off with int. So when you do that, that will go blue. So if I take that off, it goes back to black. So that knows you've got that right. So you do int, and then what happens is you would then name what you want. It can be anything. So you could use button, speaker, anything like that. But we're obviously using LEDs because I'm doing a traffic light. So I would do red because I want to plug a red LED in. I know this is probably going to go over a lot of people's heads, but obviously you can refer back to this, and if you want to play on Tinkercad, you can do so and try and write this code out for yourself. So what you do is int red space equals, I think it's equals, yeah, equals, and then you want to do pin number. So I'm going to attach my red LED to pin 10, for example. Then you have to do a semicolon. For some reason, you have to do that after every line of code. As I say, it's all to do with programming. The reasons why I'm not a pro yet, so I'm not really sure what that's about. So we're now telling the Arduino that we're going to be attaching a red LED to pin 10. Okay, that could be any pin. It can be pin 0, 1, 2, whatever. I'm doing 10. Next line, we're doing traffic lights. So you guessed it. We're going to do int yellow equals, I'm going to do pin 9 and then a semicolon. And then you guessed it, int green. I want a green LED. And we're going to do equals pin 8 semicolon. That is the first bit of code you have to do. That's all you're telling the board. And what this will do, as I said, you're giving the pin number a name. So when you're writing code, you know it's easier than remembering pin numbers. So you can just tell the code that you want the red LED to do something, or the yellow LED or something. Yeah. So next we need to do the setup, which, as Jack and Mark said earlier, which is the initial sequence when you boot this the board up. Okay, so we're going to do void, and as you see, this already comes up on the sketch. I'm just doing it again. I'm typing it in manually. So when you type in void, it will go blue, and then we're going to do setup, and then that will go green. So that shows it's right. Then no space. After setup, you want open bracket, close bracket, and then you want a brace, an open brace. Wrong button. And what that's going to do is that's sort of specifying everything below that until you do a closed brace. Yeah, so that is the first bit you need to do. You'll see it's automatically added a closed brace. So this is where we're going to write our code in between. Right, so I hope you're following along. So next we want to specify the pins and what they're going to do. Okay, so to do that, we have to type in pin, capital M, ODE for pin mode. That will go orange. Now, what we're basically telling the Arduino is if this pin is going to be an input or an output. So we want LEDs to flash, so it's going to be an output. We want the pin to output voltage to the LED. If we were to do another project and you wanted a button, that's going to be classed as an input because you want that the Arduino to detect an input in that pin to make something else in the sketch work, if that makes sense. I hope this is all making sense.
Yeah, so far.
So
yeah,
to do that, we're going to do pin mode, and then we want open bracket, and this is where we now go back to our integers, our variables. So we want pin mode red, because we're telling the board that the red LED, which is linked to pin 10, is going to be an output. So then we do a comma, and then we do space output, and that will go blue. So we're telling pin 10 is going to be an output on that pin 2. Close bracket, semicolon. That's that set up. And then obviously we're going to do the same for both of the others. So what you can do to make things easier and quicker, I'm clicking on the wrong screen. We can copy this, enter, paste, enter, paste. That code's going to be wrong. We change this red to yellow, so we're just copying what we've done above, and then we want green. So we've got the red, yellow, and green LEDs in pins 10, 9, and 8 are outputs. Then we've got our sorry, I'm just trying to, I don't know what these things are called, so I actually wrote them down. So yeah, they're the braces. So anyway, that's done. So we go past the brace. So it's saying void setup, and then between those braces is our pin mode. So we've set all of those 3 pins to outputs. And then we want to start a new line. So now this is where we want to do our void loop. Plug void loop, brackets. Oh God, excuse me. Then we want another brace. Enter, it's going to put another brace underneath. So this is, as again, the tutorial earlier, everything in this loop is what's going to replay over and over again until you tell it to stop. Okay, so I'm going to add a comment here. So we want to put the // in. So we want the green LED off. This is just a comment to say what I'm about to write. So we want the green LED off, and then we're going to then tell the yellow LED on for 3 seconds. So we want the green LED to be off and then the yellow one to come on for 3 seconds. So enter. that is now, because we've got the 2 forward slashes, that's not going to interfere with our code. That's just telling us what we're doing. Okay. So to do that, we need to write digital write with a capital R, digital write, and that's going to go orange. If we took that capital W out and just did write, lowercase, it won't go orange. That means it's wrong. So we're going to digital write, and then we want brackets, green. Again, it's going to look up. So pin 8, green. And then we want a comma. Here we go. And then we want low, which means off. Okay, and that will go green as well. So low is off, high is on. Okay, then we want close bracket and then semicolon. So we're telling the green LED to go off. Then underneath, we're going to do the same thing, and just for quickness, we're going to copy that, paste, and then we want the yellow on. So we're going to do yellow, and we want that to come on. So that's going to be high. That's that bit of code. Then we're going to delay this. So we just type in, I can't spell. We're just going to type in delay, brackets, like you saw earlier. And then I'm going to do 3000 because 3 seconds. And then, yeah, semicolon. Okay, that's that bit of code done. So let me do some forward slashes again. So we want to turn off yellow. Then we want to turn red on for 5 seconds. So digital write. What we're doing, turning off yellow. So we want yellow, low, close bracket, semicolon. That's going to turn the yellow LED off. Then we're going to do digital write, open bracket, red, high. Okay. We're going to go further down now. So
can I just add?
yes.
Everything in like the yellowy orange is what you call a function. It's a built-in for. I know it's probably really complex, but what it is that the program what you're writing your code on has these functions built in. So, for example, delay 3000 is a built-in function that tells the board to delay that light.
Yeah. Okay. Yeah. No. Thanks. Yeah. So I mean, I'm not an expert, so that's really good. You know, it just any comments like that, it just helps learn, doesn't it? I mean, I knew it changes color, wasn't really quite sure why, but I know it means it's recognized it. But yeah. So we're now digital write. So we're telling the yellow pin, which is pin 9, we're telling that to go low, which means to turn off, and we're telling the red LED in pin 10 to turn on. As we said in the comment, we want to delay that for 5 seconds. So delay, bracket, 5,000, 5 seconds, semicolon. That is that part of the code done. If you're following along on Tinkercad, this will work exactly the same. So yeah, what we want to do now is what we want to do. We want red and yellow on for 2 seconds. We want red and yellow on for 2 seconds because that's when the lights change from red to amber. You know, they're both on. So you've got to know that red is already on because we've turned red on this previous line here. So red is still on. So we want red and yellow on for 2 seconds, but red is already on. So in that case, we would write digital write, and then we want yellow. Oh, yellow. We want high. That's all we need to do because red is already on. So that red LED that we've switched on in the previous will stay up, will stay on until we tell it to turn itself off. So that's all we have to do in there, and we're going to delay that for 2. Well, I was just about to write 2 seconds, but we're coding. There we go, 2 seconds, semicolon. So I hope that follows. Okay. So next we want to, I'm going to add a comment. I'm just doing the comments to make it easy for you to see what I'm doing. So we want to.
We're losing Dana. In the comments, we're losing Dana. Sorry to interrupt. He says he's a bit confused as mine's not changing color, but he wants to know, does it not change on Tinkercad?
Oh, I think it should do.
Check your.
Right, give me a minute. Let me just let me have a look for you.
Check your case scanner because when it for the right there is a capital W.
Yeah. Let me just code something here.
Sorry, I know it's really not like you don't go comments during, but yeah.
Right, so yeah, you're right. It doesn't look like it. It doesn't actually look like it's changing color on the website. For some reason, yeah, look, delay 1,000. It's not picking that up. So don't worry about the color then if you're on the website. I mean, the void does, but the delay doesn't. So on our software that would be orange. So yeah, don't worry too much about that. Okay, so on the next bit, we want to turn off. You don't have to write these comments in, by the way. I'm just doing this so you know what each function's actually doing to our lights, just to make it that little bit easier, maybe to understand what we're doing. So next we want to turn off red and yellow. Oh, yellow. And then obviously we want to turn on green. That's what we want to do, because then red and yellow amber will go off and then it will change to green. So what we do for here is digital write, and then we want to make yellow go low, switch off, semicolon. Then we want to digital write red it doesn't matter what order you do these in. I could have put red first, but we're now going to tell red to turn off low, and we want to make green come on. So you can guess digital right green. We want that to go high, which is turn on. So we've now told yellow, red to go off, green to come on. And we're going to delay this. We're going to delay this by, what should we do? Hang on, let me think. Delay. It's the last bit of the code, so I'm going to do 15. So 15 seconds. Let's do 15 seconds. Yeah. Okay. And then you've got your code bracket. So that is basically our code written. So you'll notice, which I didn't explain at the beginning, so didn't want to confuse you too much. The reason we wrote green low right at the beginning is because the last bit of code we've written is that we want green to be the last light on, and that is currently set at high. And now I can show you this when we build the circuit. I can show you how it affects it. So that is basically our code done. Okay, that is actually quite basic. So what I'm going to do now is change to my desk, and we'll build this circuit, and then we'll upload the code and see what happens. So here we go. Let's go to the build table, and I'll explain a bit about how this works. Hopefully you can see. It's not the best view, but now one thing I haven't mentioned is the breadboard and how the breadboard works. So it's pretty self-explanatory when you know how. I've got a spare one here because I've already got this connected up. The breadboard, this one's a bit different because it's got breaks in it, so ignore this side of the board. But you've got your blue line there, which is negative. So every pin along this top line is all connected, and that's negative. And then all these bottom pins all the way along are all positive. So as you can see by mine, you've got 5 volt, which is just, it's labeled on the board. That's your power. You've got 5 volt, and I've got a jumper that goes from that pin down to the red line. So all of this plus now along here will be plus 5 volts all the way along. So it doesn't matter what you plug into this, that'll be 5 volts. Same with ground. You've actually got a few ground pins on here. You've got one up the top here that says ground, but you've got 2 at the bottom, 2 grounds. I've used one of those grounds to go down and jump into the back, which is our negative rail. So now the whole of that line is negative. So that's the first thing you have to do. You have to connect your 5 volt and ground. You've also got option for 3.3 volts, depending on what project you're doing. Okay, so this is where your jumpers come in. Now, if you're doing we won't need it for this example, but if you're doing a massive project and you need more access to more power, you can use these little jumpers that come with the kit. So you would jump from negative, which is the top rail. So I could plug this anywhere along this top rail. So I'm going to do it at the end to make it neat. I can jump that to the bottom negative rail, because right now we've only connected these top 2. This is dead at the bottom. So we can jump the negative down to the bottom. So that will feed negative from that rail into this bottom rail. And the same for positive. So you can put positive in there and join that to the bottom. That's just looping these together, so you've got power from wherever you want it. Okay, hope that makes sense. What was I saying? Right, so that's that. These pins in the middle, so that's horizontal, these are vertical. So every line in each section is its own. So you've got 5. Those 5 are connected, all of those upwards. Those 5 are connected, those 5, those 5, those 5, all the way along. And the same for these. These 5, these 5, these 5. So you've got A to J. Okay. I hope that makes sense. You'll get to know it a bit more.
Mm-hmm.
Okay, so enough of that. That's just how the breadboard works. So I'm going to get some components now. So we want some LEDs because we're doing traffic lights. So I've got 3 LEDs, green, red, and yellow. Now, oh God, look, my mind's just blown. I can't remember which is the positive now on the
The positive is the longest one.
The longest one.
Negative is the shortest one.
Yeah, thank you. I just had a mind block there.
I had to Google it quickly. I couldn't think of it either.
Yeah. So, I mean, the LEDs actually come in the box, like with super long tails. I've cut these down so they look nicer in the board. So the long one is positive. No, negative, sorry, you say?
The long one is positive.
Oh, positive, sorry. So, yeah. I'm going to put that in. The long one's positive, so I'm going to put that anywhere along here. It doesn't matter. Okay. Same for yellow. We're going to put that next to it. And then finally the green one. So now we know we've got our 3 LEDs plugged into this. All of these below this LED are going to be the positive. All of these are negative, positive, negative, positive, negative. So what we need to do now is get power to these. Now, as with LEDs, you need to use, so those of you following on Tinkercad, sorry, I forgot to explain, you're going to need one of these, your breadboard, and then just push your LEDs in. You can select LEDs in the menu and you can place them. We're going to then need resistors. So what we're going to do is put the resistors in the positive. It doesn't actually matter which way you put them, but I like to put mine in positive. So these are 220k resistors, because obviously we don't want to blow our LEDs up. So we've got one on there, on the positive leg. So as you can tell, you've got your positive that comes down into this resistor, which in turn is going to link this section of the circuit in now. So this whole row now is going to be for this side of the LED. We're going to do that with all of them. Quickly speed this up a bit.
No, it's all right.
So there we go. We've got our 3 positives of the LEDs connected to resistors. Actually, we do need this for an example. So I'm going to need to use a jumper wire because I do want power down at this bottom rail. So I'm going to do it over here. I've got plus and minus to minus. Okay. Then we want to jump from positive on our positive rail to these resistors. Now, in your kit, you probably just got wires, which you can use. So you just do positive to any of these holes below this resistor, because remember, these are vertical. So you could do that if you wanted. But for me, I've got these little jumper wires that I use. I got these. I bought them separately, and they're just ideal for bending into shape. It just makes the board look neater. So I'm going to jump from positive to any row on that resistor. Same for the other two LEDs, because we need to give absolutely forget what I've just said. My mind's gone blank. There's too much going around in my head. Forget that. You don't want that. You don't want that. I do apologize, because we want to turn these are going to be controlled by the board. So yeah, please forgive me for that. I'm just I've got too much going on, and I'm live, so it's like trying to get it right. What we do need,
Alex, just take your time.
what we do need to do is to connect all them to ground. We do need to do that. So in order to do that, you can join these in series if you want. So let's see how this works out. So I'm going from ground on this LED. I'm going to do it near the top. It's a bit fiddly to get in. I'm just going to remove that LED for the moment. Cool. So I've gone from, because we're going across them, it's fine. I've gone from the negative of this LED line. As you can see, it's in there. And that's going to jump across to the yellow LED. Or you can just jump directly from the negative to the negative rail. You can do that on each one of these, whatever you want to do. I could jump that negative to that negative, and I'm using a red wire, but that's all you've got to do. You've just got to get ground to all of those LEDs. But I'm using these nice little neat pins. Then I'm going to jump from the same negative there we're nearly done for the circuit. So negative to negative, I've dropped down one because we've occupied that pin. So same rail, negative over to the negative of the green LED. Then we want to make another connection from that negative to somewhere else, anywhere, because that's the end of the line. So we've got negative over again, which is now on this line, which we can then jump to the negative rail. This is just a super. You know what I'm like, Mark, with electronics.
I know what you like with electronics, Alex.
So I hope that makes sense. So we've jumped from negative down across to this negative pin, down to this negative pin, up there, and that's just created a negative circuit there. Now what we need to do is remember what we coded. So if I remember rightly, we did red LED. We coded to pin 10.
Yeah, K98 it went.
Yeah, so we've got some numbers on there. So it goes 0, 1, 2, 3, 4, 5, all the way up to 13. So I'm going to connect the positive. This is where I went wrong earlier. The positive of the red LED is going to go up to pin 10 on your Arduino. Okay. Yellow was pin 9. So again, positive to pin 9. Wish I had smaller cables, but and then we want green, positive goes to pin 8. And that's what we've written. That's our code we've written. I'm just going to tidy this up just so you can see what's going on. So that is our basic setup. So we've got our pins, our LEDs. I should have done that the other way around really, but you'll be able to see what's going on. So now this is where we need to come back to my screen because we're ready to upload this code. Okay, so I'm going to plug in. I'll show you it in a minute. I'm going to plug this in. I'm just going to check that my that's COM4.
Board is set correctly.
Yeah. So yeah, that's fine. That's all ready to go. And then, as you can see, I just need to remove that ticker for a minute. You can see Arduino is connected to COM4. We're going to upload this code. So we hit upload, and I should get an error. Yes, perfect. I don't know if anyone spotted my deliberate mistake. It says exit status 1, red was not declared in this scope, which basically means
The capital R.
what have I done wrong? Yeah, exactly. I didn't put the
I
capital
did
R.
spot that, but I'm new to it, so I didn't.
Well done. There you go.
Yeah, I did spot it.
Because red is coding in for the LED.
Yes.
No. Well, yeah, that's what the
For
variable.
the
That's the
pin.
name of the variable you've used for the LED.
Yeah. So I've used pin 10. I've told it it's going to be red. So when I'm writing this, I'm telling pin 10, but it doesn't find red. This is how fussy it is. Because I didn't use a capital R, it's given, and the good thing about these errors is it does highlight the line in red. So if I change that to capital R, that should now work when I upload. I'm going to make a deliberate mistake again. I'm going to remove this brace and try and upload. We should have another error. Exit status, a function definition is not allowed here before. There you go. There's your brace token. So it gives you the line, and it's saying basically it's expecting a closed brace or open brace before the next part.
Yeah, I should point out where it highlights the error. It's normally some point before where it actually outlines where the error is. So it's put that red. Obviously, it's highlighted that whole line in red.
Yep.
Normally, the error is directly before that line of code. So like it will be the line above or whatever.
Yes, yeah, and that's what we've done because obviously I deleted that brace. So if I put that brace back in, this lights up, and then this is now going to work. So
Yeah.
unless I've made another mistake that I'm not sure of, which is all possible, this should upload now to our system, and it did. Okay, spot the mistake. this was actually an accidental mistake. Can anyone spot what is wrong?
Oh, I see it.
I know Jack's seen it. Has anyone in the chat? Let's have a bit of fun. Come on, everyone in the
Yeah.
chat. What do you think is wrong with that bit of code?
Well done.
I'll give you. Oh, here we go. Look. We'll have to go through the chat in a minute because there's lots of chat.
Yeah, there's so much, but
Alex Jameson is correct. Look, I didn't use
nice.
the semicolon. Perfect. So, well done. Semicolon. I missed that. But it told me this was an accidental mistake. So yeah, it tells you it's expecting a semicolon before this token. So there's our token. As Jack said, it's normally directly above the line. There's an issue, if not on the line itself. So we were missing this. So it sort of tells you to a degree, when you get to more complicated scripts, it can get a bit daunting. You're like, what? So let's try and upload this again. I'm hoping to see no orange.
Hey.
It's gone. So now I've written that code to the Arduino. Let me go back to screen down and let's see if this is going to work. Solo layout. I unplugged this just now. We've already written the code to the EEPROM. So if I plug this in, it's obviously going to remember that code and hopefully we should see some traffic lights working. There we go. Amber. Red. Amber and red. Green. There's our traffic lights. That's going to wait 15 seconds. Hopefully turn to amber. And then red. And that is all it's going to loop. That's our loop function. So it's just replaying the traffic lights. So if you were doing a model, a diorama, and you wanted a set of traffic lights, that's how you would do it. I'd just like to go on to say, this is quite big and bulky. You wouldn't have this on your diorama. But what you would then, this is just a practice test board to get your circuits to work. So what you can then do is buy an Arduino Mini, which is a really small thing. You would then solder wires directly to the board and conceal it underneath your diorama. And then I'm guessing you would have like a traffic light, you know, a 3D printed or a model of a traffic light, which you could then embed the LEDs into. So that is our code. And it works, which is great. So back to what I was saying just before I finish up. This code, we started off with the very beginning of this code. We told it that we wanted the green low because the last one was going to be high, so on. If we took out this digital light green low, and I re-upload this, that should go through. This is what we're going to end up with. It's going to work as normal. You're going to get your red light. Amber and red. It's going to go to green. Now, because we didn't tell that green to go off right at the beginning of the code, I'm expecting that to stay on as well as amber. There you go. And that green light is now going to stay on permanently until about halfway through the script when we tell it to turn off. Actually, no, that's going to stay on all the time because we've not told green to turn off again. So that is why in our code, we need to set that to green low, because we need to tell it to do that before it starts the rest of the sequence. So I'll re-upload that, and I'll show you one more time in operation. There you go, and that should go off now because we've told it to go off at the start of the loop. Yeah, there you go. Obviously, if I disconnect the negative, all the lights, as you would expect, would go out because we've got no ground. So that is it. That is that's a little bit more advanced. I mean, well, some of you who've never done it before probably think that's really advanced, but that's quite a basic function to get going with. So I'm expecting Mark to actually be playing around with this and doing it himself. But yeah, that is my little bit for this show. Sorry it was a bit long-winded.
Well done, Alex.
That's explained it a bit.
Right, I'll go through these comments. Kaelin says, okay, got it. Thank you. That is for the Tinkercad. Alex James says, not that is going quicker. That was my board. And then Alex Jameson says, I thought you were going to type but, LOL.
Yeah.
And then we've got Neil Radcliffe. Hi, everyone. Really enjoying the stream. Thank you, Neil.
Hi, Neil. Thank you.
And then we've got D. Harris. Evening, Neil. Neil saying hi, D. Gillian saying good stream. Daniel's Universe saying I'm a bit confused. Oh yeah, we sorted that one out, didn't we?
Mm-hmm.
D saying I'm blinking enjoying this. Alex Jameson at D Harris, no pun intended, LOL. Yeah. And then Horlick says nice D. Nice.
I made a bit of an error in the chat.
Me no. Yeah. Right. And then Jack says never. Craft Chris says, evening everyone. I hope you got your power back on you, Christine.
Hi, Chris.
Jack LTV saying evening. D Harris saying at Crafter Chris, good evening. Alex Jameson says no pressure, but it better work, LOL.
No pressure, boy, but it better work.
Right. Wagler Model says don't apologise, this is very helpful. Yeah, he's put that a few times. Jordan Day says delay.
Yep.
Alex Jameson, you didn't use. Jordan Dave is missing.
Yep.
Jordan Dave says semicolon missing. He's seen it earlier.
There you go. See, look, your code already.
Jack saying nice. Alex Jameson saying it is a big and bulky, but I consider it carry on.
Yeah.
David Bassett says thanks, Alex. It's quite complex. Wagner Morris says thank you, Alex. Alex Jameson says, well done, mate.
Thank you.
Dave Matt Bill says, well done, Horlicks. I'm impressed. Jordan Day says, brilliant show. Thumbs up.
Thank you.
D. Harris says, very interesting. Good job. Like I said, you can get these kits from Amazon. I think you can get them off eBay, and they are fantastic little kits to work with. So you can go and do this, do the lessons, and yeah.
Yeah, I mean, so you've seen the lessons. When you get a kit, you get all the lessons, and it sort of explains it through. So you just play with it, you know. It's and once you start to get to know all the commands, you know, that's what happened with me. And I did this big thing, and it was actually, I won't show it because the stream's gone on tonight, but maybe on the next show I'll show you a project I did a while ago, and it involved a screen and a little show and playing Jingle Bells for a speaker.
Can I just say something, Alex? It's been at the top of the right-hand corner of the screen all through the stream.
Yes, it has. Yeah, that's my original code. That was like a little test I did with flashing lights, and you know, it is good fun. It does get a lot more complex. You know, when you start, like you'll see the intro. I did that screen, and I made it write text.
Mm.
Once you get it, it's actually all right. Like, so, yeah, it is just good fun. And another thing you could do, like we could take this further. Now, I'm not an expert, so there's a lot I don't know. You know, I'm learning as well. But you could, in theory, with this flashing, it's still going. You could, in theory, add a push button and turn it into a pedestrian crossing. Push the button, it then makes the light go red, which then lights one of the people light green, and then you can have a piezo speaker that starts beeping to say that you can cross the road for the blind. You can do all sorts like that. So
I'll be going around recoding all the traffic lights around me tomorrow.
yeah, you could do.
Just got a message off DS Models and Vintage. We got our power back. Just seeing your traffic lights, Brill.
Thank you.
Okay.
But we were playing the other day, weren't we? Like off stream, like you can do, for example, like the Route Master. If you wanted your indicators to flash independently, you could just do that. You just code it, tell it what indicator to blink, how long. You know, make it smaller, solder it up, fit it. It's as easy as that. Because once this code is on here, it's on here now until I change it otherwise. And you know, it doesn't have to be connected to. Sorry, I'm going on. I'm just trying to explain. But you don't actually have to be connected to. This is obviously feeding it power. But once you've uploaded the code, you've got no need for this USB. I haven't got a battery, but you get this in the kit. So what their code is stored on there now, so I can plug this jack in to the side, plug a 9-volt battery on there. There you go. You've got your code that you can walk around with. So that's basically how it works.
Oh, you just get one of them multi-plugs
Yes.
with the different ends, and you can just have constant power.
Yeah. You can get a power adapter for it. Yeah.
Okay.
Absolutely.
Right. Well, I've got Yorkshire Crafter says great show, very interesting to watch.
Thank you very much. Thank you. Yeah, it's been good.
Fantastic. So I think that's it for tonight. Until next week again, and we go a bit more in depth again.
Yeah, I need to think about what I'm going to do next week now. I'll have to have a think. But yeah, I would go for screens, but I think that'll be too intense right now because that'll be the second show. So I think I'll leave that for a lot later on. But.
Okay. I've got D saying, brilliant show, gents. See you on the next one.
Thank you, D.
Helen said, Waggle Mom, thanks, guys. This will be a fun series.
I'm hoping so.
Yeah. Definitely.
So
right.
now you know how to do some. You've learned a bit, Mark. I'm expecting something cool next week from you. Have a little play.
Yeah, definitely. Okay, right. Jack, do you want to say your goodbyes?
First, hello to Bose in Twitch chat.
Yes.
And I want to say, yeah, I know you missed it, Bo. It's fine. It's fine. You can watch the VOD. I would say this has been a really successful stream. This is the first time I've actually streamed from StreamYard to my Twitch. I think we're capping at 7 right now. This is the most we've had. I would say thank you for the follow to Stacey, Josh, and everyone who's contributed to Twitch chat. Thank you for everyone who's tuned in to watch the stream. Everyone who's followed, and if you haven't already, please make sure you are, because this is going to be, like I say, a really, really good series. And yeah, thank you for watching. Also, is that yeah? Bo says your room's really cool.
Okay. Yeah, I can see it. I've just seen it come up. Thank you. Right, so I'll say my goodbyes next, and Horlicks can end the show. So thanks everybody for watching. We've had an absolute fantastic audience tonight. Far more than what we thought we'd get. Thank you for everybody who's commented in the chat. And if you're going to give this a go, just do it. Just get on with it. That's what I'm doing. And I've enjoyed tonight, really have. I've actually been playing around with that LED by changing the settings quite a few times. So, but yeah, have a go. See what you can do. So good night from me, and I'll see you next week at 7 again.
Lovely. And yeah, for me, thank you very much. Yeah, as Mark just said, I mean, the response has been, yeah, mad. Like we've had so many viewers, and yeah, thank you very much. You know, it makes it all, you know, even more worth it for us to show you how this works. And you know, don't be scared to try things. That's what this is for. These test boards are for that. I mean, I haven't blown anything up yet. The only thing I have blown up is an LED because I forgot to put a resistor in once, and you get a little bit of a firework display. But I think it's pretty resilient. So yeah, don't be afraid to have a play. And if you're in doubt, use Tinkercad. You get a nice, if you do something wrong on Tinkercad, you get like a nice little animation of an explosion, which I showed these guys the other night. So it's quite funny. It's fun to play around with. But anyway, thank you so much for watching. Please subscribe to Mark. His channel is in the description. So is mine. I'm Horlicks. Mine is in the description. And also Jack, he's got his Twitch. So finding the link in the description for him as well. So until next week.
I will say, someone's asking when the next episode of this is going to be every Wednesday at 7 p.m. GMT, so British time.
Yeah, every Wednesday, 7. And as Jack said, and if you subscribe to me, Mark, I think
follow me.
I'm not sure how Twitch works. You can follow Jack, but if you also subscribe to Mark and myself, you'll be notified of when our videos are going up to be live. So yeah, that's it for me. So thank you so much for watching. It's been a pleasure, and see you next week.